All right, in this first lecture, we're going to take a look at the periodic table, and we're going to look at some of the groups on the periodic table. And the first groups that we're going to look at are the most general groups. We actually take the periodic table as chemists, and we divide the periodic table in two. And the thing that we use to divide the periodic table in two is actually already on here. It is on this printed version of the table. It is this thing right here. There's a wonderfully drawn arrow for you right there. There's another one. There's both ends of it right there. And chemists seem to mostly universally agree on this, but this is called the stair step line. Some folks call it a lot of different things, but I think most folks call it the stair step line. And that's because it looks like stairs. And that divides the table perfectly in two, right? It divides it in half, not necessarily two equal halves, right? There's the left half of the periodic table, and there's the right half of the periodic table. You've possibly seen this before. The left half of the periodic table are a group of elements that share the same properties, and we call this half of the periodic table all metals. So this is the metal side of the periodic table. And then over on the right-handed side is the non-metal side of the periodic table. This one gets tougher for me to write in, so we're going to see if I can get this right. These are the non-metals. Non-metals. There we go. Non-metals are on that side of the periodic table. So there is one more group on the periodic table that is pretty special, and it's the group that's actually hugging this line. It's hugging the stair-step line. That group right there we call the position here. These are called the Metalloids. So if you're right on the stair-step line, you are considered not a metal or a non-metal, but a metalloid. Now, we know certain properties about these elements based on whether they are metal, non-metal, or metalloid. So the other thing that we need to do, we're going to come down here below this, and we're going to make a little text box here. And I'm going to make it the same color as I drew up there. Metals. Properties of metals include a host of different things. But first of all, metals have something called luster. Luster is that shininess that metals have. It's their ability to reflect light. So if you've ever looked at something and said, oh, that looks metallic, what you're actually saying is that has luster, has the ability to reflect light. Another thing that we can do with metals is we can take them and extrude them. They can take them and pull them out very, very thin. And what that does is it means they can be drawn into thin wires without breaking. I can take any substance and make it a thin wire, right? But it may not be all one continuous piece. Metals you can draw out into a very long, thin wire. They are also malleable. And malleable is a process by which I can hammer it very thin, or I can bend it. And it doesn't break. That's the key right there, right? It does not break whenever you do that. You can bend them, you can reshape them, and they don't break into a new substance. Now, that's different than, say, clay, right, which is a different kind of substance. Hopefully, we'll get to talk about that later on in the semester. But a metal like gold or copper, you can hammer very, very thin. We've already talked about gold, right, the gold foil experiment. Why did he use gold? Well, because you can hammer it very, very thin. Lastly, they conduct heat, and they also conduct electricity. So thank goodness for that, because they are, excuse me, we're using those right now. We're using those to be on the computer and use the internet, right? These are things that we need metals to conduct electricity for. And then the last thing is sort of a chemistry thing. It's really important, and it's going to be very, very important next week. What we see is that metals actually also tend to lose electrons to form ions. So most of the time, you're going to find out next week when we're talking about this, most of the time these metals tend to form ions by losing electrons. And now we're going to make another chart here. Oops, I didn't mean to change the color of that one. And now when they're there, it's hard to tell which color is which. What we're going to do is we're going to talk about nonmetals. And I love to make a reference, as somebody who has two sisters, I make a reference to the fact that nonmetals, sort of, the only way that we talk about them is by comparing them back to metals. So it's sort of like a sibling rivalry sort of thing here. I'm sure nonmetals, if they had any thoughts or emotions whatsoever, wouldn't appreciate always being compared. But que sera, such is the way it is. So if metals have luster, nonmetals do not. They are dull, right? Which means they are not shiny. Not shiny. They cannot be drawn into wires without breaking, and they can't be hammered very thin without breaking. So both of those are brittle. Right? Brittle means not ductile or malleable. And they are insulators. Most of the time in chemistry, we're more worried about them being insulators of electricity. We don't so much worry about, most of the time they're insulators of heat is what we're concerned with, not so much the electricity part, but we can put it both insulators. They do not conduct heat or electricity. There we go. Can I spell electricity correctly? Yes, I can. Eventually, there we go. And then because atoms of metals tend to lose electrons to form ions, atoms of metals tend to gain electrons to form ions. So those are metals versus nonmetals. And then we get to the weirdos in the middle. Again, going back to the sibling analogy, right? We've got the middle sibling here. Not to insult any middle siblings, but literally metalloids are in between metals and nonmetals. And I called them weirdos because they are different than metals and nonmetals. They have their own unique personality. And what that unique personality is, I'm going to use, because the green text is very hard to read, I'm going to use black text for the metalloids. Metalloids have whatever property of metals or nonmetals they want. They have properties of both metals and nonmetals. And depending on what state they're in, depending on what they're next to, they're going to sometimes behave like metals and sometimes behave like nonmetals. And when you look at the metalloids, when you look at this stair-step line, to borrow this, I'm going to move the metalloids for just a second here. If we look at this, there are 8 elements that occur on the stair-step line. Now, some people draw that stair-step line down and include astatine in there. I'm not one of those people. My stair-step line ends here, and it's great. There are 8 elements that border this. One of those elements is not a metalloid. All right, so if you always remember that, hey, there are 8 here, and there's one that is not a metalloid. By the way, 8 minus 1 is 7, right? 7 metalloids. Which one is not a metalloid? Well, there's one of these that is always a metal. And you have seen it before if you've ever drank a Coke out of a can, or Diet Coke or Coke Zero, or list any other soft drink here. You drank it out of an aluminum can. Aluminum is a metal. It is very strictly a metal. It always behaves as a metal. It never behaves as a nonmetal. Boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, however, can borrow traits from both. Some chemists have argued about polonium, and they want to say polonium is a metal, but I want to make life simple, so I include it with the metalloids. I've never seen a sample of polonium myself. It is a radioactive element, so I'm not a big fan of holding radioactive elements, but maybe one day. But anyways, metalloids, there are 7. There are 7 on the chart, and they are boron. We can look up here, see boron, silicon, germanium. Look at the next 2, silicon and germanium, arsenic and antimony, tellurium, and polonium. And those are the 3 groups. So If I were to give you an element and were to ask you, for example, ruthenium, would you expect it to gain or lose electrons? You'd say it loses because it's a metal. If I were to ask you about chlorine, what would you expect chlorine to do? You would say, I expect it to gain electrons because it's a nonmetal. You couldn't tell these these 7, you could not tell what they were going to do based off of that. So that would be an I don't know, depends on the situation kind of thing. All right, next lesson is on the specific groups within each of these sort of more general groups. And last thing I'll do is move metalloids back up where they belong.